Hi, I'm Sanket, co-founder and CEO of DeepSource. We're excited to announce DeepSource SCA, an intelligent supply chain security product that helps you secure your open source dependencies with static analysis and AI. In this video, I'm going to show you how to use DeepSource SCA on your repository, discover vulnerabilities and where they are affecting your code, and automatically fixing them with Autofix AI. I've set up a sample repository with some vulnerabilities that we can use to test. So the first thing that you need to do is, if you're already a DeepSource user, you will see a new dependencies tab. And in this dependencies tab, all the targets that we have found in your repository, and each target is a combination of a log file and a package manifest, those will show up. So if you're already a user, just go to the dependencies tab and click on sync all targets. And this is going to take a couple of seconds. And what this is going to do is it will discover all the targets that we have found. Now, in this case, this is a Python repository. The target that we have detected is a combination of pyproject.toml and poetry.lock. What we're going to do is we're going to activate analysis right here. And this means DeepSource has discovered the target. It's scanning all the dependencies for vulnerabilities that we could find. And we'll just give it a few seconds and we'll see how this shows up. So once the initial analysis is completed, you will see that DeepSource has detected some vulnerabilities. So we're going to click on this and we'll see what's going on. All right. So on the left side, you will see that we have detected 30 vulnerabilities in this repository. 29 of them are in direct dependencies. One of those vulnerabilities is in a transitive dependency. You can also click on the packages tab here, and you can see all the different dependencies you have and where these dependencies exist. What is the tag? Looks like in this test repo, all of them are production dependencies, but you would see if you're using tags for different package managers where you're tagging your dependencies as development only or test only, those will show up here. Now for each repository in the vulnerabilities tab, you will see all the vulnerabilities that we have detected. Let me walk you through some of these tags. So you'll see the tag unreachable or reachable. DeepSource does reachability analysis for you to understand how each vulnerability actually impacts your source code. So we're going to click on this vulnerability and see that there are 9 reachable call paths, which means the way that you're using this package, this vulnerability that's getting introduced, it's impacting your code base in 9 places. And you can cycle through this to see where these reachable call paths are. And this means that this vulnerability actually impacts your source code in 9 different places. Now, this is super important information because traditional SCA tools usually do not show you if the vulnerability is actually reachable or it's actually impacting your first party code. Some tools do show you the reachability information, but they don't actually show you the context of the code where your code is actually vulnerable. And DeepSource does that. Since we have built DeepSource SCA on top of our existing static analysis platform, we are able to understand your code very well, and we are able to correlate vulnerability information with your code. So we are able to show you the reachable call paths all in context. Now let's take a moment to understand this view first. You know which package and which version is this vulnerability is in. You see when this vulnerability was published, which versions it was introduced in, which versions it was fixed in, and then you see the CVSS scores and EPSS scores, which are useful for you to understand how severe or how important fixing this vulnerability is for your security posture. We also have the reachability. In this case, since this is reachable, this vulnerability is reachable, you see reachability as reachable. And since we can automatically fix it, you'll see an automatically fixable tag here. We're going to come back to implied severity and dynamic risk a little later. But first, let's try to fix this When you click on the Autofix button here, you'd see that DeepSource has automatically generated the fix for this vulnerability. And you'll see in this case, the vulnerability existed in Flask version 1.02, and the fix that we are suggesting is in version 3.10. In addition to showing you the fixes, DeepSource is also doing a bunch of other analysis to help you understand if this upgrade is safe for you to do or not. For each of the upgrade paths, we currently judge the upgrade path based on three things: version risk, dependency type risk, and compatibility risk. And we use an AI agent to go and figure out what is changing between these two versions for you to understand very easily what is happening and should you be directly upgrading or not. In this case, it looks like this is a major upgrade. It's getting upgraded from version 1 to 3, so there is some risk there. It's updating a direct dependency, so that's another risk. But overall, we think that even though there are different risk vectors, we think that it's a high risk upgrade. But we're going to go and apply this fix with a pull request anyway. And all you need to do is click on apply fix. And what DeepSource is going to do is it will automatically create a pull request on your repository with this fix. All right, looks like the pull request is ready, and you'll see a view PR button here. And when you click through that, you'll be taken to GitHub, where you can see that DeepSource has created a pull request for upgrading the Flask version, in this case, from 1.02 to 3.10. We have added a helpful description with references, with a small description on what's happening here. And then when you click on the files change, you will see that DeepSource has upgraded the poetry log file. It has also upgraded the TOML file, correctly upgrading the other dependencies as well. Now let's take an example of another vulnerability. In this vulnerability, we see that it's also reachable, so we're going to try to autofix it. And here we see that DeepSource is recommending two upgrade paths. This is super important. Not all upgrades are made equal. Traditional SCA tools will show you only the latest upgrade, or they're going to naively suggest that just upgrade to the latest version and everything will be well. DeepSource doesn't do that. When we are trying to figure out the upgrade paths of a vulnerability, we're actually parsing your entire dependency tree and figuring out all the upgrades available which fix this vulnerability. In this case, this package where we have the vulnerability in version 0.14.1, we see that DeepSource is recommending that you upgrade to 0.15.5 where the fix has been applied, or you can also do a major upgrade to version 3.13, which also fixes this vulnerability. Now, a traditional SCA tool will just tell you that, hey, just upgrade to version 3 and everything will be fine. That's not practical all the time. And this is one of the key things that we have built. We call this Multivaried Autofix AI, which figures out all the ways that you can upgrade this dependency to fix this. And if we look at this version seems safe. It says needs caution because it is a minor update, so there could be things that could be changing. But it's overall much safer than our second option here, which is a major update, and where the dependency type risk, it's also updating a direct dependency, and it could be problematic. So what we're going to do is, in this case, since DeepSource is recommending this version, we're going to click on apply fix with pull request, and the same thing, DeepSource is going to figure out how to upgrade this. It's going to go and automatically create a pull request for this package. We have a lot of different ways for you to understand how many vulnerabilities do you have and which vulnerabilities are important to you. On the left side, you can filter based on different factors like severity, reachability, fixability, and then dynamic risk. Again, I'll come to dynamic risk in a moment. But let's talk about these three. The severity comes from the inherent severity that has been applied on the CVE. This comes from your CVSS scores. Reachability, you can filter by reachability to understand which vulnerabilities are reachable, and these are the vulnerabilities that you should be focusing more on. Fixability shows you which of these upgrades is possible for DeepSource to do automatically. Now let's come to dynamic risk. Usually, security teams use factors like CVSS vulnerabilities and EPSS scores to understand how severe or how important a vulnerability is. But that's not enough. The way that organizations look at their risk depends on various factors about the organization's context. So what we have done is we have invented a new scoring system where you get to decide what's important for you. Let me show how that works. When you go to policies, you will see a dynamic risk setting. Now, what a dynamic risk does is it prioritizes, or rather it assigns scores to each vulnerability based on a combination of CVSS scores, EPSS scores, and reachability. We spoke to hundreds of security teams to understand how they'd like to prioritize their vulnerabilities, and the answer we've got was they'd like to tune what is important to them. So what you can do here is you can define what is more important to you. You can tell DeepSource how much do you weigh each of these factors in your prioritization model by just changing these values. If your security team decides that CVSS is more important than EPSS, you can do that here. You can define how important the EPSS percentile is. For instance, you'll emphasize higher percentiles more strongly if you only want to focus on high-risk vulnerabilities. So setting it to something like cubic will basically dampen the vulnerabilities with lower EPSS percentile way more and increase the priority of vulnerabilities that have a higher EPSS percentile. Then you can define the reachability weights. Now these four factors help you create a very versatile model of judging how important a vulnerability is for your org. Now once you have changed these values, we'll go back to the repositories and we'll see how the dependencies change. The moment that you change those values here, we will automatically update the dynamic risk for each vulnerability. So in this case, you see one of these vulnerabilities is now imminent, which is the highest level of dynamic risk. This framework will help security teams create their customized model for vulnerability prioritization, so you do not have to be boxed in by just CVSS scores or EPSS scores. And finally, DeepSource runs all of these SCA checks continuously on every pull request with baseline analysis. So you can create custom gates to keep insecure vulnerabilities out from the new packages that are being added. So if you go to the Policies tab, and in the SCA vulnerabilities section, you'll be able to define vulnerability gates based on all of these different factors. You can customize when you want to block a pull request if DeepSource detects a new vulnerable package in the PR. So you've got settings for dependency type, dependency group, where you can define production, development, test, documentation dependencies, severities, reachability, fixability, and others. This way you can create a very flexible gate to match what's important for your security team at this point. Once the pull request analysis is enabled, every time a developer makes a pull request, in addition to DeepSource's regular code analysis checks, you would see DeepSource running baseline analysis for SCA across all the targets that have enabled. If something fails, DeepSource, as usual, will fail that check, and that will show up in the History tab where you can go and fix those issues. We are excited to get DeepSource SCA out in the hands of everyone. We have also priced DeepSource SCA transparently per target. In addition to the existing platform, you can pay per target without any other limits and start using SCA from today. The free plan comes with 3 targets, so if you're on any existing paid plans on DeepSource, or if you're on the free plan, you already have 3 targets that you can enable and start getting a feel of how DeepSource SCA feels. Once again, we are super excited for this release, and if you have any questions, please reach out to us. Please reach out to us on our support channels. If you have an account manager, please reach out to them. We are super excited for you to try DeepSource SCA. Until next time.